So now we have fully understood latitude. Let's look at the other direction. Let's look at longitude. Now here is an important distinction. When we were talking about the lines of latitude, the horizontal lines moving up from the equator to the poles and down from the equator to the other pole, they went up between 0 and 90 degrees. The pole is the natural endpoint. It is where the axis of the Earth's rotation comes out of the ground. But with longitude, now these are the vertical lines that go from the North Pole to the South Pole. There's no such place. You can rotate the entire world all the way around, and there's no special place of any great distinction in terms of the Earth's motion. What it means is that as the Earth turns relative to the Sun is overhead in different places, and that the Sun is overhead, where it is overhead, moves to the west as the whole planet rotates towards the east. It means that the Sun passes overhead of different longitudes at different times. Now we divide from the 0 line, and we'll talk about what that is in a minute, the lines of longitude all the way up to 180 degrees west to the opposite side and 180 degrees east to the other side. And so rather than counting to 90 and stopping, we count all the way around to the backside, which is 180 degrees away from the front. So if we have no pole or other natural feature which will help us figure out where to draw our lines, where to put the first line and draw every line relative to it, someone has to pick somewhere. What we know is that a 2nd century Greek geographer from Tyre in Lebanon, in modern day Lebanon, he was called Marinus. And what he decided to do was to place things at a distance from the Canary Islands, and drew the Canary Islands as the far left part of his map, because that was the extent of the known world at the time. There was nothing beyond the Canary Islands as far as they were aware. Now in the same century, but slightly further south in Alexandria, Claudius Ptolemy created a map using travellers' reports and mathematical calculations to draw a detailed map of the world. And it starts with this sharp line that runs straight through the Canary Islands. And there you can see it. This is the actual map. The Canary Islands are on the far left, to the left there of Africa. And what you can see is the entire world. And it features, yes, to the left, we have the Canary Islands, we have the Sahara Desert to the bottom, we have the United Kingdom. Scandinavia is not on this map, wasn't discovered at that point. And we can go to the far east. China appears on this map, but it gets a little bit more distorted as the stories about it get a little bit more vague. But what you can also see on this map are the first lines of longitude drawn. You can see them drawn all over the map. They represent equal divisions of distance as you move around the world. So with everyone drawing their maps all relative to the Canary Islands, things changed when we started to find things that were further than the Canary Islands. So when Christopher Columbus in the late 1490s discovered the New World, there was a bit of a land grab. The countries of Spain and Portugal, who already had extensive empires in Africa, decided to, rather than go to war over these territories, they decided to make a legal pact which decided who would have which lands to colonize. And so what they decided was that everywhere in this middle bit here, to 1,770 kilometers west of the Cape Verde Islands, that all belonged to Portugal. Every new colony had to be Portuguese. Further west of that, which would include most of the Northern American continents, would belong to Spain. And this was actually drawn up in the Treaty of Tordesillas and overseen by King Ferdinand II and Queen Isabella of Spain, and by King John II of Portugal, and overseen by the Pope at the time. These vertical lines on the map were of great significance, and it actually still is evident in the languages spoken by people in certain parts of the world, whether or not it was one side of these vertical lines or the other. Was it Portuguese or was it Spanish speaking? In 1675, King Charles II thought it really important that navigators should know where they are at sea. It seemed to be that though we could always figure out by astronomy what our latitude was, we had no way of figuring out what our longitude was. And so to improve this, created the Greenwich Observatory. Now this was associated with not only trying to find an astronomical solution to working out what your longitude was, it was connected to time. Because what they did at the Greenwich Observatory is they indicated to the ships that were down in the port and down in the River Thames that it was local noon by having a big red ball visibly drop on the roof. And we still use ball dropping as a way of marking that it is midday or midnight. For example, in Times Square in New York at New Year's Eve, the ball drops, and that is how New Yorkers celebrate the New Year. Now, because it was so heavily associated with this, the setting of time and the establishment of when it was noon, the Royal Greenwich Observatory would take a very important part in the establishment of the Prime Meridian. Various different countries like France and the Netherlands and Spain established their own prime meridians that their own ships would use. But the Americans adopted the British prime meridian that ran through the actual gardens of the Royal Greenwich Observatory. And this was in 1884. And because the Americans did it, everyone else would have to do it. And so it was established worldwide that the prime meridian, the point at which east and west occurs, the point at which we measure all time relative against, was drawn right through the middle of London. It also passes France and Spain, so they can't be too unhappy about it, but also North Africa and a slice of Antarctica. The line continues around the back of the world, crossing only a small region of northern Russia, and then mainly going over the Pacific Ocean. So this, between the prime meridian and going out towards the ante-meridian, basically divides the Earth into the Western Hemisphere and the Eastern Hemisphere. So remember, we have two different distinctions here. We could say the North or the Southern Hemisphere, drawing a line through the equator, or the East and the Western Hemisphere, drawing a line through the prime meridian. And from our point of view, it basically enabled it to be a little bit easier when we were labeling things. For example, all of those places to the far east, we could call such. We could call them the East Indies. All of those places to the far west, we could call the West Indies. And so even in places in America, everywhere west was the Wild West. And so we can use these words east and west to describe physical places on the Earth. Now the lines of longitude march off around the world. And here you can see them at 10-degree points. And what is very surprising, I think, to most people is that there are places in Ireland further west than anywhere in mainland Spain or Portugal. Ireland actually sticks out. It actually goes over the 10-degree west marker, whereas the furthest point west in Portugal is at 9-point-something degrees. So it's not quite sticks out as far. Now the sun actually manages to travel about 15 degrees every single hour. So though the sun would be above our heads now, we would find it above the far western point of Africa in an hour's time. An hour before now, we would find that the sun was over places like Italy and Sweden. So here are those lines, the lines of longitude as they go around the world. And it's very easy to calculate that figure. If we know the Earth turns 360 degrees in 24 hours, well, 360 degrees divided by 24 hours gives about 15 degrees per hour. That is just how far the noon point has shifted to the west as the Earth turns underneath it. Now, noon. If it was noon here, what we might find is that it is definitely not noon in Sweden, being 15 degrees of longitude towards the east. What we would find is that its noon, the point when the sun was highest in the sky, actually happened an hour ago. And so therefore, it doesn't make sense to represent noon across the world at the same time as it is noon in London. In fact, what they do is they use a time zone, which says that region says that noon is approximately at this time. Now, ultimately, when it is noon, it is only noon at that time for that exact meridian, that one line that runs from the North Pole to the South Pole. It is not quite noon yet everywhere to the west, and it has already been noon everywhere to the east, and that line moves across the Earth where it is noon. Now, in the 1800s, they realized that you couldn't always just use your own noon as the noon. If you went on a train journey, for example, you would need it to, your time would have to be the same time as wherever you went to. So the building of railways across the United Kingdom meant that they had to establish a time zone. And as soon as they did it here, they had to do it everywhere. What we find is there are some time zones that are quite wide. They're drawn on political lines rather than any kind of desire to keep it true to the local noon. It means that in some places, the midday happens way before the local noon, and in some places it's the other way around. When I was recently in northern Norway, the northernmost point, the local noon was about 20 minutes after it said midday on my watch. And so we get these slight differences. It also shows that a country as large as the United States has 4 different time zones. You might hear of Eastern Standard Time or such thing. Now, the time zone that runs through the UK, the time zone that is relative to the Prime Meridian, we call that universal time. And in a global world, as well as the local time, most countries in different time zones that are reporting on things that have international interest would also quote the universal time. The universal time is the time that we have in this country through the winter months. We, of course, change the time. We put the clocks back for an hour in the, we put them forward in spring and we put them back in autumn to shift where the daylight hours are relative to our own day, just to fit people's work and waking patterns a little bit better and make people a little bit more productive. That is what we do. We have this extra thing called British summertime. But basically, in winter, we follow this thing, universal time, UT, sometimes called Greenwich Mean Time, named after the Royal Greenwich Observatory. So the Royal Greenwich Observatory was set up with a problem in mind. They wanted to figure out, for sailors, how you could figure out how far round the world you'd gone, what was your longitude. And they tried to find astronomical solutions for this. Some early work indicated that if only we could know what time it was in London and we could compare that to our local noon. If we found our local noon was 1 hour after the noon in London, then we could guess that we were 15 degrees around the world. The problem is we never know what time it was in London. As soon as you get out of sight of London, you can no longer see the ball drop on the Royal Greenwich Observatory. So how do we know what time it was in London? We need some way of recording what the time was. We can observe local noon just by looking at the sun, where we are. But the time in London is more difficult. Now, up to this point, clocks were basically grandfather clocks or sand dials or some such thing, not very accurate. But with the invention of the grandfather clock, we could use the pendulum to accurately keep time. The problem was on a ship, the movement of the ship would knock out the motion of the pendulum and the clock would run wrong. You would have no way of figuring out what time it was. So one chap called John Harrison, he had the idea of, well, if the ship is moving, we could counteract every movement with a movement in the opposite direction. And so he created this ingenious chronometer with which he said you could always find out what time it was in London, and it was small enough to fit in a room on a ship. But the people that governed the prize said it wasn't good enough, it was impractical, and it could break. So what John Harrison basically invented was this, the pocket watch. It was a small compact watch which would always tell the time in London, against which you could tell your local noon and work out just how many degrees of longitude you were, west or east of the Greenwich Meridian.